Hi students, in this video we are going to discuss about the Kirchoff rules and the numericals. Numericals on Kirchoff rules. Kirchoff rules, numericals. Today I am going to discuss. Before starting the session, I'll give some sign conventions. Kirchoff rules already you learned. Sign conventions. Then I'll proceed the session. Sign convention. Before starting the sign convention, you keep it in your mind. Whenever you are, I will talk some terminology here like a loop direction and a high potential, low potential like this. What does it mean? See, when I am going from higher potential region to lower potential region, and you are moving higher potential to lower potential, here potential drop happens. Potential drop, see, high to low, potential drop. The potential drop, I'll take it as a negative sign convention. This is the first point you need to remember. The second point, when you are going from lower potential to higher potential, in your loop direction, lower potential to higher potential if you go, then potential gain happens. This potential gain, I will take it as positive sign. See, these sign conventions are completely our choice. Whatever, suppose some textbooks, different textbooks follow differently, but I feel this is convenient for me. I am following this one. Higher potential region to lower potential, it's a drop should be negative. Lower potential to higher potential, potential gain I am taking as positive. Clear? Now some example, you keep it in your mind. Going in a loop like this from A to B, in the direction of A to B, current is flowing like this. Let it be resistance R. I am moving from point A to B. From point A to B, some current is exist in the wire or branch of resistance R. Now, what is the potential drop or potential difference between A and B? What to take the potential difference between A and B, positive or negative like this? Here, very simple, current always flows from high potential region to low potential region. We studied in the class 10th also same thing. Higher potential region to lower potentials, current will flow. Higher region to lower region. That means higher to low you are going, that should be potential drop is going to happen. Potential drop always, I told you, negative. What it is negative as per Ohm's law? Minus IR. See, I am going from my loop direction, loop from A to B, loop from A to B, and current direction also A to B. That means higher potential to lower potential, then potential drop minus IR. Second point you remember. Suppose let it be I am going from A to B. My loop from A to B, but my here in this loop current is in this branch current opposite to my loop direction, that is from B to A. See, current will flow from higher potential region to lower potential region, higher potential region to lower potential region, but your loop direction from A to B, see here, this is my loop direction. This is my loop direction. Loop direction is opposite to the direction of current flow, or else you are going from lower potential region to higher potential region. Potential gain is going to happen. This potential gain we can choose it as plus IR. Earlier, higher potential region to lower potential region, potential drop in your loop direction minus IR. Now potential gain plus IR. Clear? For example, I will give you, there is a 4 ohm resistance, 2 ampere current, it is from B to C, loop C to B, loop C to B, that means like this. This is your loop direction. If your loop direction is opposite to the direction of current flow, here potential gain we can write it as plus IR plus 2 into 4, which is 8 volt plus 8 volt, like this. Current I 2 ampere, this is 4 ohm from B to C. Loop also same direction. Loop direction also same as the current direction. Then potential drop will happen. Potential drop is minus IR, which is minus 2 into 4, which is minus 8 volt. Hope it is clear. Next, third point you remember, this is your loop direction. You are going from A to B. In the direction of A to B, there is a battery exist of EMF E. You are moving from negative terminal to positive terminal. Potential gain always plus, that means plus E. Suppose you are moving from A to B. From A to B I am going, this is my loop direction, but in this I am moving from higher potential to, that means positive terminal of the battery, to negative terminal of the battery. Potential drop should be negative, minus E. These points you keep it in your mind. Based on this, now we are going to start the numericals. The first one, 2 volt, 2 ohm, 1 volt, 1 ohm. Here 2 ohm resistance is there, 2 ohm, and here one 3 volt battery, 3 volt battery. This is the given question. 3 ohm resistor, 1 volt battery. Here again 1 ohm resistance. This is the circuit given. They also mentioned the names like A, B, C, D. A, B, C, D, and the question they are asking, find potential difference between B and D. This is the question. Find the potential difference between B and D, and there is one more question. What is the potential difference across terminal of 3 volt battery, a 3 volt cell? This is the question. See students, the question is given like a 2 volt battery and 2 ohm resistance, then 1 volt battery, 1 ohm, A to B, B to C, C to D, and D to A, and B to D, one resistance is the 2 ohm. Now they are asking to find What is the potential difference between B and D? This kind of questions, how to proceed? See once. Carefully follow. First question is find the potential difference between B and D. Now I am going to solve this one. Later I will do potential difference between 3-volt battery. See how I am going to solve. I will select until they specified the current direction. I will choose my own current direction. I will take from the current from 3-volt battery. I current is going to come out. Then till here same current I, till here same current I. Why? Because there is no junctions. At this point B there is a junction. This current is going to divide. How it is going to divide? Let it be, I will say this is I1. At point B the current enters I1 is divides. Then see how I am going to tell. This is point B, I enters like this, I1 goes. How much current will go like this? Let it be X. We know the current rules. I enters, I1 leaves, X leaves, then entering current I equal to leaving current I1 plus X. Then X should be I minus I1. Then this current is I minus I1. Clear? Once again I will tell you. At B I current enters, then I1 leaves like this, and this should be I minus I1. Same thing here I represent. Then coming to this point, till here I minus I1 will come. Here also I minus I1, here also I minus I1. Why? Because there is no junctions. Junction means minimum more than 2 branches it has to go. Here the same current, there is no chance of dividing that. But here see 3 are there, up to here it is going to divide. Then the same I minus I1 comes here, I minus I1 till here. Then this I1 at junction D, what happens? See, at junction D, I minus I1 enters like this, I1 enters like this, and something is going to comes out. Let it be Y. Entering currents I and I minus I1 is equal to leaving current Y. I1 gets cancelled. I equal to Y. That means here it is I. See how the currents divided. Total current I is there coming from the battery 3 volt. That I is going to till B same it will maintain. At B it is going to divide I1, I minus I1. Then this I minus I1 till D it will continue. At this junction D, this I minus I1 and this I1 will meet and it will become I at this point. Now I'll choose the loops. Loop A, B, T, A. I'm going to take the loop A, B, D, A like this. A to B, then B to D and D to A. In this loop A, B, D, A, the loop A, B, D, A, how I am going to find the Kirchoff's second rule. How I am going to apply the Kirchoff's second rule. Now see students carefully. A to B there is a battery, plus terminal to minus terminal, higher potential terminal to lower potential terminal you are moving, then it should be minus 2. Plus 2 minus, that means higher terminal to lower terminal, minus 2. And see the current direction. Current is moving B to A, but your motion A to B. Then it should be plus I minus I1 into 2. Next, then A to B over. Now I am moving from B to D, this along the diagonal B to D. B to D current and your B to D you are going like this, current also same direction. Then again it should be minus. Why? Because potential drop. Minus 2i1. Minus 2i1. Okay. Next d to a. D to a, how you are going? D to a, you are going like this, but current is coming from A to D. Current is from A to D, you are moving from D to A. It should be plus 1 into I into R, 1 into I minus I1. Loop completed. Equal to 0. Minus 2 plus 2I minus 2I1 minus 2I1 plus I minus I1 equal to 0. After completing the equation, once again you check carefully. If any sign mistake is there, you won't get any proper answer. You will get wrong answers. Minus 2, see once again, minus 2 plus 2 into I minus I1, then it is 2 into minus 2 into I1 plus 1 into I minus I1. Yes, see here one mistake is there. I skipped this battery. See, that's why I told you have to do very carefully. I skip the battery. Minus, here minus terminal to plus terminal, minus 1 volt, not minus, minus to plus, that means potential gain should be 1 plus 1 equal to 0. So that's why I told carefully you do, students. Minus 2. Okay, let me solve. Similar terms, you write minus 2i1 minus i1, which is minus 3i1. Here one more minus 2i1 is there, which is 2 to 4 minus 5i1, 2i plus I, 3i minus 2 plus 1, which is minus 1 equal to 0, which is 3i minus 5i1 equal to 1, equation number 1. See, still if you have any doubts, you see the carefully. I am going to take one more loop. That loop is B, C, second loop. This is first loop. Second loop I am going to consider loop B, C, D, B. Loop B, C, D, B. B to C, you are going from negative to positive battery. That means plus 1 volt potential gain. Then current direction is going upward, but your motion is downward. Your loop direction is downward. Then plus 1 into I into R, like this. But again C to D, 3 ohm, but current direction and your loop direction, you are going like this. You are going like this. Current direction opposite, plus 3I, and battery positive to negative, minus 3. Coming to the diagonal element, see I am entering diagonal D to B, current is opposite B to D, that should be plus 2I1 equal to 0. You have to do very carefully. 1 plus 3I plus I, 4I minus 3 plus 2I1 equal to 0, which is 4I minus 2I1 minus 2 equal to 0. We will get the equation 4I, check it once. Sorry, this is plus 2I1. See, that's what. Carefully you do it. 4I plus 2I1 equal to 2. Equation number 2. 4I plus 2I1 equal to 2. Solve equation 1 and 2. What is equation 1? Equation 1 is 3I minus 5I1 equal to 1. Equation 2, 4I plus 2i1 equal to 2. 4i plus 2i1 equal to 2. Now I want to find, what is the question? Find the potential difference between B and D. Then I want to find current I1. I eliminate the I terms. How to eliminate? Here 4 is there, here 3 is there. How to eliminate? You do one thing. To cancel this 4 and 3, you multiply this one with a 4. Equation 1 into 4. Why? Because 4 into 3. 12i minus 20i1 equal to 4. Equation 2 into 3, which is 12i plus 6i1 equal to 12. Subtract. 12i 12i gets cancelled. Minus 26i1 equal to minus 8. I1 equal to is it correct? 4 sorry 3 2s are 6 only. This is minus 2. 4 minus 6 is minus 2. I1 equal to 2 by 26, which is 1 by 13 ampere. The current in this I1 equal to 1 by 13 ampere. See, from B to D, 2 ohm resistance is there. Current is 1 by 13 ampere. What is the potential difference between B and D, which is I into R? I is 1 by 13, resistance is 2, which is 2 by 13 volt. Potential difference is 2 by 13 ohm. Clear? IR 2 into 1 by 3. Once again check it, how I did it. And what is the second question? Second question, they are asking find potential difference or terminal potential difference. Terminal potential difference across 3 volt cell. 3 volt cell is like this. See the diagram. Three volt. This is 3 ohm. Potential difference across this one. Current is I. Current is I. It is like B, D and C. D and C. Potential difference between D and C they are asking, or else C minus D. I'll say VC minus VD, how to calculate. See, similarly I'll apply like a Kirchoff rules. See carefully how I'm going. I'm going from C to D. Here potential I'll say VC. Here I'll say potential VD. But how to write? Carefully you see VC, VC, and you are going from C to D. Your motion is from C to D like this. C to D VC. Then your direction is opposite to the direction of did I calculate I value here? No, I1 is 1 by 3. What is I? From this 3i equal minus 5 into 1 by 13 equal to 1. 3i equal to 1 plus 5 by 13. 3i equal to 18 by 13. I equal to 6 by 13 ampere. Yes, now you have the current. 6 by 13 ampere. See, now VC, then you are going opposite to the direction of current. Current is like this, your motion is opposite to the current direction, plus IR, that means I is 6 by 13, resistance is 3, and you are going from higher potential to lower potential, minus 3, equal to VD you need to write here, this point VD. Then VC minus VD equal to 6 3s are 18 by 13 plus minus 18 by 13 plus 3, or else 3 minus 18 by 13 volt. Simplified. 3 minus 18 by 13. 39 minus 18 by 13. Think you will get this one, 21 by 13 volt, like this. If you have doubt, I'll tell you how to calculate one more thing. What is the potential difference across? Suppose one more question. Find potential difference across B to C, that is 1 volt. Potential difference across B to C. In the circuit like this, B, this is 1 volt, 1 ohm, this is C. Current is going like this. What is that current? I itself it is going. Now how to calculate potential difference between B and C or C and V? I want to find VC minus VB. Suppose how to calculate VC minus VB? You say here potential C, here potential is B, VC. You are going in the direction of current. See, this is your loop direction, C to B. Minus 1 into I and plus 2 minus potential drop minus 1 equal to VB. Then VC minus VB equal to I plus 1. I plus 1. I is just now you calculated 6 by 13, I think. 6 by 13, correct. 6 by 13 plus 1, which is 19 by 13. Like this we calculate. Students, once again you check it. How I am following current division. First you have to do current division carefully. After the current division, after the current direction, you take how many unknown variables are there, those many number of loops you need to consider. Here I have the unknown variables I1, only 2 unknown variables, 2 equations. This is one loop, this is second loop. 2 equations enough to solve this. After that I simplified. I find the current I1. Then what is the question? What is the first question? Potential difference between B and D. Across B and D only resistance is there. Then potential difference across B and D is I1 into R. I1 is 1 by 13 into R is 2 by 13 volt. But if you see between D and C, resistor is there, voltage is there, I mean potential battery is there. How to calculate? Like this, between D and C, I want to find VC minus VD. I'll say potential at C is VC, potential at D is VD. Then loop direction is like this. Your loop direction is like this. Our current direction is opposite. That's why I write I into R plus IR, 6 by 13 into 3. Plus terminal to lower terminal minus 3 equal to VD. Then I calculated this one. Similarly, I calculated between C and V also. VC minus VB. Here I said VC, here it is VB. VC minus VB equal to, how I am going to calculate VC? This is same direction, minus 1I plus 2 minus 1V equal to VB. Then VC minus VB equal to I plus 1. 16 is 6 by 13 plus 1, which is 19 by 13 volt.